All right, so we're going to be looking at the Graphing Quadratics help sheet. I see that I'm going to use the equation y equals x plus 1 squared minus 16 as my example as I go through here. Let's look at the graphing form of a quadratic equation. Y equals a times x minus h squared plus k. Now, what information does this give us immediately? This gives us the vertex in the form of h comma k. Now notice this is doing x minus h. So I got to keep that in mind that when this is negative, this is positive or vice versa. So let's take a look. What is the vertex of y equals x plus 1 squared minus 16? Well, minus h minus, and again, plus 1 is a negative 1. So remember that switches sign, and the 16, or the negative 16 says negative 16. Let's put this on the graph and label it. So negative 1, negative 16 is my vertex. So down here, negative 1, negative 16 is my vertex. Which, by the way, is also where you find your line of symmetry. Okay, now let's say we don't start with this graphing form. Then what? Well, let's look at the standard form. This is the one that we've practiced more. Y equals ax squared plus bx plus c. How do I move from graphing to standard? Multiply and simplify. Okay, so let's look at y equals x plus 1 squared minus 16. What would be our first step? Well, we need to multiply x plus 1 times x plus 1. What's the easy way to multiply this? Don't forget, FOIL. So let's multiply it. So I've got x plus 1 times x plus 1. F first, x times x is x squared. O, outer, x times 1 is a positive x. I, inner, 1 times x is a positive x. L, last, 1 times 1 is 1. So now I can simplify this. X squared plus 2x plus 1. Now let's take this expression and put in the negative 16. Where did this come from? Well, if you look up here, we haven't dealt with that part of the equation yet. All we've done to simplify this is multiply. We've got to add this in to simplify. So I've got x squared plus 2x plus 1 minus 16. So when I simplify, my standard form, y equals x squared plus 2x minus 15. This is our standard form. What can I do with this then? Well, how do we know the y-intercept looking at this? Don't forget, y-intercept is when x equals 0. So let's take a look at this up here. If I have a 0 here and a 0 here, what remains? The c in the ax squared plus bx plus c, right? So the c is the y-intercept. X equals 0, and our c value is a negative 15. Let's put this one on the graph. So 0, negative 15. And this is the x-intercept. Oh, sorry, y. This is the y-intercept, not x. Okay. How can I find the x-intercepts or the roots of this quadratic equation? Does this look familiar? It should. All right, so remember, x squared goes in the bottom left, negative 15 goes on the right. X squared times negative 15 is negative 15x squared. That goes up here. Okay, so then remember the middle part of the bx goes in the bottom of my diamond, so 2x. Remember, if I've got a and b, this is a times b and this is a plus b. So I need to think to myself, what times what is negative 15? What plus what is a positive 2? Well, I know 5 times negative 3 is negative 15. 5 plus negative 3 is 2. So I've got 5x and I've got negative 3x. So 5x and negative 3x. Okay, so the next part of it is we're going to be filling in the part of the generic rectangle. So what goes up here? That would be an x. X times 5 is 5x. X times x is x squared. 5 times negative 3 is negative 15. So remember, these become our product. So x minus 3 times x plus 5 equals 0. So what values of x make this true? We could have 3 minus 3 equals 0, so x equals 3. Negative 5 plus 5 equals 0, so I could have x equals a negative 5. These are my roots, also known as my x-intercepts. So let's get these on there. So x equals 3 up here. Here's 3. And then at negative 5, these are my x-intercepts. Now, I've got enough information to graph on already. So a couple things. Remember, the vertex is your line of symmetry. So I'm just going to draw a dotted line. You don't have to do this, as I'm just kind of doing this to remind you this is what this part is. So anything that happens on the left also happens on the right, which means that since I know my y-intercept, I also know this one right here. Now, let's go ahead and take a moment and get this graphed. Like that. And same thing in this direction. Like that. Is this a perfect graph? By no means, but I have my important points on here, and I've got them roughly connected. So this is the basics for finding how to graph the quadratics. But let's look at one last thing. Let's say that you're only given the standard form, which means we don't have the graphing form to help us with the vertex. How would I find the vertex if I only had the standard form? Remember, this is halfway between the roots. Okay? So, what is halfway between 3 and negative 5? Well, that means 4 apart. So, halfway between negative 5 and 3 is x equal 1. So this is the x value of my vertex, and we can already, negative 1. We can already verify that because we already know our vertex. But now, how do we figure this out? Well, let's plug it into my quadratic equation. Y equals negative 1 squared plus 2 times negative 1 minus 15. Negative times negative is a positive, so this is a 1. 2 times negative 1 is a minus 2, minus 15. So this is negative 16. Y equals negative 16. So negative 1, negative 16, I was able to find without the graphing form. So that's the last way you can find your vertex if you don't have the other form. There you go.